SWIR sensor that was manufactured in high volume, which from technology perspective is a huge breakthrough. We are working with leading OEMs and tier ones globally. We really like the German OEMs and tier ones, and we have great connections already. Pleasure to be here and to discuss about whatever you like.
Mm-hmm. Thank you very much, Avi. Now, Simon, would you like to introduce you? And actually also, what is your background? Why are you here to represent BMW in this topic of autonomous driving?
Yeah, thank you, Ludmilla, for the kind introduction and for moderating the session. So let me start a little bit with my background. So I have a strong background on automated driving. So this was especially for the time when I was a research assistant at the University of the Federal Armed Forces here in Munich. I was working there for 7 years till 2001, and by that point in time, we built the first real automated vehicle, a vision-based one, and this was the famous German Prometheus project by that point in time, and we managed to drive by that point in time on public highways with up to 180 kilometers in real time, of course, yeah. So this is a long time ago, was research, and then, as you see right now, it is taking more than 20 years to make real products out of that research results we gained by that point in time. After that, I had a major shift, and then I went into functional safety, because this is the key point to make all this happen, of course, that the systems are really safe. I'm one of the authors of ISO 26262 and other safety activities. And with that, I also had a next major step in platform software at BMW, being Mr. AutoSAR for many, many years, rolling out the AutoSAR platform in all BMW vehicles in 2015, from there on now. And then when we started our new division on automated driving systems, I changed to that, and right now I'm principal expert on that. And of course, right now we are working on our first generation to be released by this year. So the public press announcement will be exactly on the same day as of today for the new iX and i4 full electric vehicles. Then they will have for the first time our new ADAS AD technology stack. And then, of course, right now we already start working on the next generation after that. And this is exactly where, of course, we are in a very open and then close exchange with many, many tech players to get the latest and greatest technology in our vehicles.
Thank you very much.
I always enjoy these kind of open exchanges here. Thank you.
Yeah. Thank you. We will definitely come to that, to deepen this discussion. And now, Doron, would you like to introduce yourself and what you are focusing now on outside automotive?
Mm-hmm. First of all, good morning. Thank you very much for having me. My name is Doron Coadier. I'm the Vice President here at Foresight Automotive in Business Development. And just to briefly explain a little bit what we do at Foresight Automotive. We're a software company in which we're developing a 3D perception stereo vision software solution for the automotive industry. Just to make it short, what actually in the bottom line do we actually provide with what we do is actually, first of all, it's a hybrid approach between classified detection and non-classified. Basically detecting any object. It could be the classified object like a vehicle or a pedestrian, but it can be a rock, any animal, a tree that fell on the road, a box that fell off a truck, you name it, we'll detect it. In addition to that, we add the ability to detect under harsh weather lighting condition using thermal technology. We provide, again, as using stereo, very dense 3D point clouds. Okay, really impressive point clouds using vision cameras. Very importantly, we're a passive technology, as opposed to other active technology which emit sorts of an energy to hit the object and get a reflection. We're passive, and therefore we're less prone to mutual interferences between sensors. I think one of the most interesting things, the most disruptive technology piece that we're providing here is taking stereo technology to the future. What do we mean by that? Traditional stereo is actually mounting two cameras on a rigid bar behind the windshield. Basically, we developed a technology that allows now to separate the two cameras from this rigid bar, enabled by the automatic calibration feature we developed, which is, by the way, camera agnostic. And by doing so, by developing this automatic calibration, we can now keep the two cameras calibrated at any given time using software, and therefore achieve, first of all, flexible placement of the cameras. I can put them now much more different places in the roof racks, side mirrors, headlamps, you name it. Second, increase accuracy, distance accuracy of the cameras, because the further you move them apart, it's more accurate, and achieve much long distances. So really, this is really in a nutshell what we do, and taking basically stereo to the future. Thank you.
Thank you very much. And actually, let's start now with this discussion, actually, and I will jump right away now in the topic what you mentioned. And actually, when we talk about those kind of technologies, the question is not just about the technology, but also about the cost. For example, when we talk about LiDAR, super expensive and so on, can you give us a little bit of comparison between those technologies? So where do we find your technology? Doron, you're on mute. Yeah.
The mute button, I missed it. Again, what we're actually developing, as I mentioned earlier, we're developing 3D point clouds. 3D point clouds based on cameras. Cameras today, for example, visible cameras are very cheap. And now we can actually put them at any point, as I mentioned earlier, on the vehicle and produce a very dense point clouds. We showed even that even with VGA, low resolution cameras, we can achieve very high quality dense point clouds. I think the main advantage here of using it, 3D point clouds using cameras, obviously you mentioned the cost, which is quite obvious here, but it's not only the cost, it's the dense, the amount of resolution, because in the end of the day, everything lies down in the amount of pixels you can see an object. And we can achieve, even with low res, looking very far away, we can detect obstacles which, for example, LiDARs struggle in reaching these amount of pixels, because again, the more pixels you have, the better the detection, the better classification. And we can achieve this using Vision 3D point cloud. In addition to that, we can use higher frame rates. Okay, we can achieve it in different spectrums as well. Okay, I mentioned using thermal. So we can provide a 3D thermal point cloud in order to deal with harsh weather lighting conditions. Being passive, I mentioned being passive. LiDAR, for example, sends out a laser to hit an object and get a reflection back. So we actually stare in the environment and collect what's out there. So we're passive, less prone to mutual interferences. And this is a problem that I think the OEM has started to pick up, because there aren't too many of these systems out there as of yet. When the roads will be more crowded with this, there's more noise created by a lot of sensors, and therefore it's better to use passive as opposed to active sensors. Mm-hmm. I think this really, in a nutshell, summarize it.
Thank you so far. Christina, actually, now a question for you, because we all know from the media how important is what you do within the Volkswagen Group. And actually, what is the future roadmap for your technologies, actually?
Okay, so our aim is that starting from 2025, all new vehicles from Volkswagen Group will have our new platform, which is around 10 million vehicles per year. And CARIAD, we are not only doing autonomous driving, we also doing intelligent cockpit and body. Also, we are doing vehicle motion, energy, and also digital businesses and mobility services. But when we come to autonomous driving, our aim right now is to go to level 3 and then beyond level 3. So if I don't know if you know, so the different levels autonomous driving. So the question is, what is autonomous driving? There is a definition between level 0 and level 5. So level 0 would be no autonomous driving, so normal driving. The driver is completely in charge, and there's almost no assistance to the driver. And level 5, where the driver can sleep, and in any kind of environment, the driver can, the car can drive alone. So starting from level 3.
One little question in between. Yeah. Where do you see yourself now currently in the development stage?
So we are right now, we have in fact already some commercial vehicles that you can acquire today, and they already have some level 2 functions. So level 3 is the moment where in some use cases, the car can drive alone, and the driver does not need to be always in charge. The driver has some time to still react. So the system will tell the driver, hey, please now you are in charge, please take now the control of the car. Level 2 is where in some environments, some use cases, the car can drive alone, but the driver has always to be alert. And that's something, by the way, that it's now commercially available. For example, the e-tron, Audi e-tron has it, some functionalities of level 2. I have sent you a video, Ludmilla, about it. So if there is some time, we can put it.
If we can organize it now, let's watch right now.
Okay, yeah, as you wish.
Nicholas, could you please switch the video on? I guess we have all to make on mute so that we
keys approaching. Okay, so all sensors take positions. Commander?
All right, let's do this. Everybody ready? This is our time to shine. We're picking up a parking command on the app. Let's welcome our driver.
Top view cams, what have you got for me?
Top view camera online.
Ultrasound crew.
There is an obstacle to the rear of the vehicle, to the right, to the left of the vehicle, at 19.27 inches. There is no obstruction in front of the vehicle.
Radar sensors.
No objects appearing in wider range.
Surroundings fully calculated.
Mr. Actuator, start the engine. And engage automated parking. Engage transmission, select D. And slowly pull vehicle out of the parking spot. Returning controls over to driver.
Ah, guys, I'm blinded. I can't see a thing.
Well, sight is overrated anyway.
All good. I'm back in the
No
game and copy that
obstacles
too. There's no pedestrians, cyclists,
Copy
or cars
that.
in front of us.
No obstacle for the next 36.8 feet.
Excellent, thank you.
Wow, people, there's lots going on here. There's pedestrians on the street, cars in front of us, cars approaching, pedestrians, cars parking, trucks on the road. Really busy out there, but we got it under control.
Sensing an object approaching on our right.
Front camera, what can you see?
I can tell you with certainty that it's a bicycle.
A bicycle?
Cyclist approaching on the right.
Impending collision at 5 seconds. Preparing emergency brake. 3, 2, 1. Engage emergency brake. Wow, brilliant job. Thank you. Let's offer him Audi AI Traffic Jam Pilot.
Sensor, are you ready?
Check! He pressed it, I knew he would!
The route has been changed. Please take the next exit on the right.
We're coming out of the traffic jam. But why?
Well, well, looks like he's taking control again.
Are you seriously pretending to drive?
Leave him alone. Let him practice for the country roads.
Thank you for some insights and for some humor involved. Now everyone is definitely awake now. So, Avi, let's talk about the recent collaboration you announced and what does it mean to you actually? And by recent, I mean just some days ago, because you had also some other ones.
Sure. So, as I said before, we are already working with some German tier ones and OEM in a great collaboration. We recently announced a collaboration with Continental, one of the leading tier one worldwide, for a DMS application, driving monitoring system, which is an in-cabin application that helping the main computer to understand if the driver is distracted or have any other issue. The advantage that we bring to the table is the ability to function in any lighting, being eye safe and more. But maybe I'd like to discuss more about the collaboration in general, or because I cannot go into details with a specific company. I think that, look, we are coming from Israel, which is a very small country in the Middle East. We don't have an automotive industry in Israel, nothing similar, maybe army stuff, but nothing similar to the automotive. And I think that the beauty in those type of collaboration, the ones that we announce publicly, like with the Porsche or with Conti, is that each one of the companies brings a lot of in-depth and professionalism to the table, and actually complete the full offering. If it's in ADAS or if it's in the DMS domain, it doesn't really matter. The fact that Tri-Eye as a company, maybe in the recent years we did acquire knowledge in the automotive domain, but I think that this is not our strong place. We're coming from the semiconductor domain, from the ability to manufacture and innovation from the sensing capabilities, and working together with the professional from our German colleagues. This is great. Like you see. Simon briefly discussed about his experience with the qualification and the amount of details that you need to verify and to take sensor out of the box into a vehicle on the road is tremendous. And the fact that working together with those type of companies, that's the only way, in my eyes at least, to bring it to be a reality. So I'm really thank you for the opportunity and give confidence in what we are doing. So this is on the high level.
Thank you very much. And now, Simon, also the same question for you, like before to Christina. What is your future roadmap now for the technologies you develop? And also, because I think it's very interesting to know at which level, so from 0 to 5, are you now currently in the development stage? So behind the scenes at BMW Group.
Okay, yeah. So as you might know, of course, I can not tell you all the secrets behind the scene, but what's officially
just the
known,
ones you can tell.
Yeah, I tell you as much as possible. Yeah, of course, we have currently much more than 20 level 2 features in the current production vehicles. Yeah, so this is a quite impressive amount of features, but at the end, it's a lot of, let's say, separate features. And what we currently work on is, of course, to make a continuous experience out of that for level 2. And I think fundamentally, everybody, it's not only BMW, is at the key question, how far can we go with level 2 plus or level 2 plus plus, however we name it. So how far can we go with systems that take over the certain, let's say, parts of the driving, so the dynamic driving task, to say it like that, but the driver is always, as a supervisor in the loop, needs to be alert, needs to take over control again in case the system is not reacting or operating correctly. And of course, this is something where you have to go very deeply into human-machine interaction issues and let's say also human capabilities to monitor systems. And this is, of course, where I think the industry in general, this is not speaking right now for BMW, is reaching a certain limit very soon. And for that reason, of course, everybody is going into the level 3 activities. And when you have a look back at the hype of the recent years, when everybody was speaking about level 4 urban and stuff like that, this will definitely come later, as we have really learned from reality and missed announcement dates from many companies. But what we definitely will see is that we can realize the technology, but it will come in smaller steps. Yeah. So, and for that reason, I expect that we will have very soon on the roads what we name a traffic jam pilot in general. So it goes up to a limited speed. Traffic jams is typically, let's say, 60 kilometers per hour maximum, potentially for short times 80 kilometers per hour. And it's always in a condensed traffic scenario where you have a very well-defined scenario, and then you really can hand over the control to the vehicle. The driver gets out of the loop. This is what Christina already introduced as the level 3 function, and the vehicle actively gets the driver back into the loop when the traffic jam is over or for whatever other reason. And this is what I see will come within the next 2 to 3 years, that we have this very first level 3 functions really on the road in customer vehicles. And then, of course, I think, and this is what we really need to understand, the whole thing is a data-driven development cycle and learning cycle. So when we have these vehicles on the road, we can, let's say, really grab a lot of data, gather a lot of data, and use this for the further development of the systems. And I think this is the essential part, that we start with small ODDs, so operational design domains like traffic jam pilot, get a lot of information and data out of these vehicles, also when the L3 system is not active, and can use this to further push the development forwards into larger ODDs. So I think when this step is taking place right now, then this will be an evolutionary process that is really a data-driven development process then.
Simon, when you are saying that it will come later than we first thought, and it will come in smaller steps, now you are talking just about the technical side, right? Or about also regulation and how it will be accepted by law and so on, or just really the technical side?
Good point you're mentioning here. Thank you for giving this hint. My main focus and explanation right now, of course, was on the technical side, but in parallel, you have also to see the regulatory side. And this is, of course, I think there we have 3 major regions on the world. This is the UNECE region, so mainly driven by Europe, but very similar than in China, in Japan and in Korea, where we're making great steps. L3 traffic jam pilots are ready. There's a regulatory act available since last year, and they are expanding that into the next, let's say, extended ODD. So here we have good progress ongoing. And of course, the situation in US and China is slightly differently. And this is, let's say, the second point you, as an OEM, always have to precisely consider, can we really make the business there? Can we really bring these vehicles to the road? Is the regulatory ready to go at the end? Yeah.
Mm-hmm. Will definitely come.
This is not a worldwide harmonized thing. This is, let's say, 3 main regions on the world we have here, to my understanding.
Now, actually, to everyone, we will definitely come to that topic of regulation as well. Now, let's first return back to the technological side, and a question to Doron. You mentioned the USP and what is going well. So, but where are the challenges for you? What are you developing now? Also, like for everyone, the thing you can mention.
Yeah, again, you're talking from a technological aspect, yes?
Exactly. Yeah.
Okay. We didn't mention what I did mention what else we can do with our automatic calibration, but basically what we're taking it now, and we announced it just recently, we have our first proof of concept of actually enhancing existing ADAS systems. So we teamed up with a well-known European OEM to show what we can do with existing ADAS systems. So basically, we're